In this video, we will find the fluid force on a semicircular vertical plate. The question states, a semicircular plate with a radius of 4 meters is submerged in water with its top 3 meters below the surface. The density of the water is 9,800 newtons per cubic meter. Find the fluid force on the plate. So first, notice that the force is the pressure times the area, and the pressure is the weight density times the depth. The weight density is 9,800 newtons per cubic meter, so W is 9,800. The depth, if I draw a cross-section right about here and let x equals 0 correspond to the bottom of the semicircle, then from bottom to top is 7 meters, and from bottom to the cross-section is x meters. So the cross-section to the top will be 7 minus x meters. So I get h equals 7 minus x. Now let's go find the area. The area is going to be the area of this small cross-section we think is a rectangle. The length of this rectangle, or the base, is 2a. A is the distance from here to this semicircle, so it's 2a. And the width is a little bit of a delta x. So area equals 2a delta x. Now we need to find a in terms of x. And our friend the Pythagorean theorem comes on in. We can say that a squared plus x squared is 16. Solving for a, we get a as the square root of 16 minus x squared. Now we could put that into the area formula. And the area is 2 times the square root of 16 minus x squared times delta x. Now we could put this all together and write down that the force is equal to the pressure, which is the weight density, times the depth, 7 minus x, times the area. Now just might as well multiply 9,800 times 2, which I do here, and I get 19,600. And there's my force for that one small cross-section. I want all of the force for all cross-sections, so I add them up and take a limit as the little height of that cross-section approaches 0. I get an integral. The total force will be the integral of 19,600 from 0 to 4, because the smallest x gets is 0 and the largest is 4, of the 7 minus x times the square root of 16 minus x squared dx. To work that out, I'm going to break this up into two integrals. First, I'm going to say, well, that's 7 times all of this, and 7 times 19,600 is 137,200, and I have the square root left. And then I have minus, and then the x times the square root. This first integral here, this is the integral from 0 to 4 of the square root of 16 minus x squared. That's just the area of the quarter circle of radius 4. For the second integral, what I'm going to do is I'm going to do a little u substitution. So I'm going to let u equal 16 minus x squared, and then du is negative 2x dx. There's my x dx. And what I get is the first one, remember, was the area of this quarter circle. And the second, I can write in terms of u. So I worked that out, and what I got was 1,724,110 minus 418,133. The final answer is 1,305,970 newtons of fluid force on our semicircular plate. And I'm done with the problem.